Single out salute. I'm Lord Maitreya, the hip hop futurist. You're now tuned into the Super Longevity Institute podcast. Today, we will discuss the evolution of aging with Dr. Michael Rose. He's the director and professor at the Department of Ecology and Evolutionary Biology. Dr. Rose is one of the world's leading scientists in the field of aging and human evolution. Welcome to the podcast, Dr. Rose. It's a pleasure to have you.
Thank you so
Um,
much.
how you feeling today? How's the weather where
Great.
you at?
The high today was about 80 degrees Fahrenheit.
Oh man, I wish I was on the. You're on the West Coast, right?
I'm in Irvine, California.
Oh man, I want to be on the West Coast. It's a little chilly over here. Fall is just setting in, so we gotta wear a light jacket, nice little hat, keep you warm, little scarf. Oh,
Okay.
so what have you been up to since the? What have you? What have you been into since this pandemic? Because we're not able to move around like we used to. So what have you been up to? I know I just been doing this podcast. I mean, I work in a hospital, but I've been just doing this podcast and trying to stay busy doing that with my free time. Because usually, I have other things that I'm doing. I usually have two jobs at once, so
Well,
I never really have time.
well, just let me say thank you for your work in the hospital.
Yes, thank you.
We need all the hospital workers we can get,
Yeah.
and hopefully you'll stay alive and stay safe and stay good.
Hmm.
As for me, I'm a 65-year-old professor. I've made the transition from teaching in person.
Hmm.
I gave my last live class in early March.
Hmm.
And ever since then, everything I've done has been virtual.
Hmm.
So I'm teaching a course as we speak using asynchronous audiovisual tools.
Hmm.
So my students have all this videotape of me and others and
Hmm.
uh, PowerPoint decks they can go through and text that I'd already written.
Hmm.
And I'm also giving a lot of talks, both to conferences and to people like yourself. This is
Hmm.
actually my second interview of the day.
Oh, wonderful. So you're busy. I'm glad to hear that. Um, Dr. Rose, can you give us a little bit of your educational background? How'd you got into the field of evolutionary biology, and what brought you? When did you come to the idea that it'd be possible to reverse the aging process?
Okay, that won't be two sentences.
Oh, good.
So
Take the floor.
uh, I sort of fell in love with evolution when I was 13 years old in high school. I actually was given an excellent course in comparative anatomy,
Mm-hmm.
and I did all kinds of dissections of all kinds of animals.
Mm-hmm.
And we were also taught, some of the elements of the history of evolutionary biology. Um, when I went to college at 15, I was determined to become a biologist of some type, maybe even a physician. But
Mm-hmm.
within a year and a half, I'd say, of college, I became really interested in biological research.
Mm-hmm.
And my first interest was in the interface between ecology and evolution. That started when I was 18. Um, I did 2 degrees in Canada.
Mm-hmm.
And then in 1976, I went to England for a PhD.
Mm-hmm.
And for my PhD, my advisors told me that I had to work on aging.
Mm-hmm. Wow.
And at the time, I really didn't understand why that would be a good idea.
Mm-hmm.
So they explained it to me.
Mm-hmm.
They did a serious year-long campaign to get me up to speed, and they eventually succeeded.
Wow.
And since late 1976 until now, 44 years, I've been working on the problem of aging.
Wow. You put in work. Thank
It's
you
been a
for
while.
that. Yeah.
It's
Wow.
been my pleasure.
Wow. Wow. Um, Can you share with us the experiment you did with fruit flies? And
Well, the first really good experiment that I did
mm,
was based pretty directly on evolutionary theory. There's this little parameter in the theory for the evolution of aging, which many people have personal experience with, which is the first stage at which you biologically reproduce. So that's when you have your first child,
mm,
how old you were then. So the first stage at which anybody in a population, like think of everybody you knew in high school, has a baby is a really important parameter in evolutionary theory because that's the age at which aging starts. And so, unsurprisingly to evolutionary biologists, a lot of human physiological functions peak between the ages of 12 and 14, just before you start to get into trouble with the opposite sex.
right.
Because it's the actual biological act of reproduction that counts, not recreation. That's sort of preliminary to
Right.
that act. So I took that parameter very seriously, and I was taking care of some populations of fruit flies. So I said to myself, what if I create a new population derived from this first population? And the population I started with normally started to reproduce biologically at 14 days. These were fruit flies. I said, well, what if I take a population and I reproduce them at 28 days instead of 14 days, delaying when every individual in this population reproduces by at least 14 days. Then the evolutionary theory suggested to me that this population on its own over the next 10 or 20 generations should evolve delayed aging. And that's what happened over the next year.
Wow.
I did that experiment in the 1970s. And since then, that experiment has been done over and over again by myself, my students, and others all around the world, and it always works.
Wow. Incredible. And incredible it was that long ago. So uh I seen you do an interview with Jane, I think his name is Jim Straw from People's Unlimited for the Rad Fest. And you said something that was very interesting to me. I said, no, I gotta ask him this when he comes to the show
Sure,
personally. You
go
said
for it.
the technology is hard, but the science is straightforward. I said I gotta ask him. What did you mean by that um statement when you was talking to Jim? You remember that you said something? I don't know if that's a direct quote. It's
I,
close enough.
I've been saying that for, more than 30 years.
Right.
Um, I published a book called Evolutionary Biology of Aging in 1991, about 30 years ago. And there I argued that aging, literally I said this in the book, that aging is a solved scientific problem, even though it's an unsolved medical problem. So I meant that in the same way that, genetics is a solved scientific problem. It's not a completely solved problem in terms of all the genetic problems that people face. But, we know what genes are. We know exactly what they are. We know all the genes in the human body. We have pretty good ideas about what a majority of them do. And we're on our way to figuring out the details. And in particular, the next 10 or 20 years are going to see a lot of the genetic diseases really resolved, like sickle cell anemia, one of the most common genetic diseases in the United States.
Yeah.
Within 10, 15 years, that's going to be gone as a medical
Wow.
problem. And that's because we have such powerful genetic science, which has enabled us to build very powerful genetic interventions. So our genetically is extremely powerful because we have this really deep understanding of genetics in all organisms, okay? Now, the basic ideas of genetics were worked out by the 1930s. And after 1950, we added molecular genetics to the genetic package. So that by the 1980s, we could really do everything that we wanted to do. All right? Now, my assertion is that by 1990, we'd worked out the key scientific ideas. And since 1990, we've been working on more and more of the molecular foundations that undergird those ideas. Okay? And, in 1980, I published in the journal Nature one of the first modern evolutionary biology of aging articles. That was the first time I reported on the evolution of postponed aging. And in 2010, we published the first, in my opinion, good paper on the genomics of aging, and especially the genomics of delayed aging. And since 2010, we've done more and more genomics. Last year, we published our first transcriptomics. We're working on a metabolomic project. And what all these omics say, what omics means is you're doing the whole damn thing all at once. So when you're talking about the genomics of aging, you're talking about everything that goes on across the entire genome with respect to aging. When you're talking about the transcriptome, you're talking about everything that goes on with all the transcripts. Now, right now, we're working on those papers still with fruit flies. There's a beautiful thing about both genomics and transcriptomics, and that is we can map all the DNA sequences in a fly to a human. We can map all the transcripts in a fly to human transcripts. So the beautiful thing about the universe of genomics, which is not specific to aging, it's the same thing is true of all genomic technologies, is the information can be taken from one species to another really easily. So we're now, since 2010, we're racing toward more and more of the details of how the genomics, the transcriptomics, the metabolomics, that means all the metabolites in the body change when you substantially postpone aging. And we're doing that in the hope of learning, well, what matters most when you really want to retune the aging process? And unfortunately, it turns out it's not one thing. It's not a single gene.
Right.
It's not two genes. It's not two pathways. It's not 7 pathways, which is what most cell molecular reductionists will try to convince you of. Unfortunately, the answer is typically many. And by many, I mean hundreds. However, the beautiful news is that we now have machine learning technologies that enable us to make sense of hundreds of genetic differences, leading to hundreds of transcript differences, leading to hundreds of metabolic differences, leading to hundreds of physiological differences in all the medical things that you see every day in a hospital. Okay? So machine learning, artificial intelligence, will show us the way, because it's very clear that the reality of what's going on is more complicated than the unaided human mind can figure out. Okay? But we don't have to worry about that because we have the AI, we have the machine learning. So I regard the project of doing for people what I've done with fruit flies, which is substantially postpone aging, as a difficult problem, but an eminently doable problem. The science is basically done. We're now moving into a technological phase. And my hope is to leave the university and start working for companies full time to enable them to work on transforming the human aging process.
Wow. Let me just ask you a question, a little side note. Are you still on the paleo diet?
Yes, I am.
Oh, you are. Oh, okay, wonderful.
Yes.
Okay.
Yeah, I just had a ribeye steak with mushrooms and
Oh,
avocado.
nice.
Thank you.
Hmm.
I cooked it myself.
That's
Uh,
good.
so in 2016, I published a paper called Four Steps Toward the Control of Aging. And the first step is accepting the evolutionary biology of aging, which, believe it or not, the majority of people in the aging field do not.
Oh,
They don't accept it. Yeah,
wow.
yeah, because they're committed to all kinds of ideas that, in the opinion of many evolutionary biologists, are simply wrong. And the second step is adopting an age and ancestry appropriate lifestyle, which means, put simply, that the farther you go forward in your biological age, the farther back you need to go in your evolutionary ancestry to emulate how your ancestors lived,
Mm-hmm.
ate, and everything else. So that varies from person to person all around the world, but uh, your ancestry is one of the problems, technological problems we've completely solved. Like, we can give you from your genome a lot of information about your ancestors.
Right.
Then we have a fair amount of historical and anthropological data on how those ancestors lived and died. First, 200 years ago, then 2,000 years ago, then 20,000 years ago, and so on. And the thing about uh, our ancestry is that the majority of people alive today come from populations that adopted agriculture between 5 and 15,000 years ago. Now, what that means is that people with that kind of background, who are primarily Eurasians, are pretty good at eating an agricultural diet up until the age of 30 because of the way evolution by natural selection works. Evolution by natural selection adapts the young to a new environment really fast, in dozens to hundreds of generations. But the older you get, the more you're a relic of your ancestry. So the fact of the matter is that 20,000 years ago, we were all hunter-gatherers.
Right.
So 20,000 years ago, none of us ate bread. None of us drank milk from another animal.
Right.
Okay. So what that means is, when you're old enough, if you have a Eurasian ancestry, you have to stop consuming those things. By contrast, if your background is indigenous Australian or indigenous New Guinea, you should never have those kinds of foods in your whole life, because your ancestors never adapted to them. And for other populations, like the indigenous populations of the Americas or sub-Saharan Africa, there's only a comparatively recent and limited adoption of agriculture. So now there's a fringe benefit from your ancestors never having adopted an agricultural diet, is that we know exactly what the best diet is for you through your whole life. And with people like me, it's a bit of a crapshoot. So so that means, between the ages of 15 and 40, people with Eurasian ancestry will be somewhat adapted to the agricultural foods that their ancestors ate. But it's going to be fading steadily all through that time. Well, now I'm 65. I have essentially no adaptation to agricultural foods, so I don't eat them.
Right. Right.
Okay. And it's very important to add that no human being alive is adapted to the Twinkie Red Bull diet. So if you're trying to survive on Twinkies and Red Bull, you're destroying your health.
Right. Right.
That's true of everyone at every age, all the time,
Right.
no exceptions.
Right.
And so accepting the limitations of evolutionary biology and human ancestry is a very important part of being healthy. Okay. So, once you turn 40, 45, you have to completely give up on agricultural foods. So concretely, that means no pizza, as you've come to know it and love it. Sorry,
Right.
I'm a pizza lover too, but I
Yeah.
haven't had pizza in decades. So that's just a brutal fact.
Wow.
Okay. Now I will just tell you anecdotally that every one of my friends and colleagues whom I have convinced of this idea and who've taken my advice hardcore, every single one has experienced improved health and function.
No, I believe in the paleo diet. I really do. I think
Yeah.
that it's definitely scientifically sound from what I know.
And everybody who's over 40 and has made the transition has totally experienced it for themselves.
Wow.
Um, and there's a ton of data actually on Australian populations, indigenous Australian populations, who are never really adapted to agriculture. You get spectacular results in terms of health improvement and recovery for them.
Really? Oh.
Yeah, spectacular. That's really well documented.
Wow. I'm glad you shared that with us because uh, in the hip hop community, we definitely need to step it up as far as diet is concerned. And most of the famous people in our culture right now is over 40, by the way. So you guys, you got to step it up and maybe try something different. You never know; it may work for you. Paleo diet worked for
And
me.
yeah, I'll simply say that the less Eurasian your ancestry, the better it will work.
Right. That makes sense. Okay.
Yeah.
Wow.
And there's some very deep things there that are, for the hip hop community and your fans, those of you who have less Eurasian ancestry, the benefits will be much greater than they are for someone like me.
Wow.
Because I've sort of been polluted, genomically speaking, by adaptation to agricultural foods. So there's a certain amount of health benefit that I can't get back from switching to a paleo diet that people with sub-Saharan African ancestry will definitely be able to get back with, I think, pretty radical consequences for long-term health.
Well, in the African American community, you know not to drink no milk. We know we can't digest milk,
Perfect
dairy.
example.
You
Perfect
can't digest
example.
dairy. Stop it.
Yeah.
Yeah.
But the same thing is true of bread,
Same thing. Yeah,
you know?
that's true. That's right.
Yeah. You just got to walk away from that stuff.
Yeah. Bread is hard for me. I love
Oh,
bread.
bread contains addictive substances.
Oh, it's not. I'm not
Really.
surprised.
It really does. I mean, and they have psychological effects, those addictive substances.
I'm not surprised. I love bread, baguettes, love
I do too.
bagels.
I,
I love this
I
stuff.
haven't had bread in, God, I couldn't tell you how long.
I'm gonna tighten up, though, Dr. Michael Rose. I'm gonna tighten up. I'm not. I'm gonna stop eating bread. I'm gonna make a really big effort. Nurses stop giving me bread at the job. Maitreya does not eat bread anymore after the show. I have to talk to Dr. Michael Rose. Do not give me bagels in the morning. Thank you. I love you, but
And
stop
and
it.
and let me say something really surprising, which you can rarely say in biology, which is you get increasing returns. The more hardcore you go, the more benefit you get. It's really quite amazing.
Well, it looks like it's doing well for you. You're 65. I mean, you looking great, man, over there. I mean, it looks like it's doing well for you,
Well,
bro. I'm gonna tell you the
thank
truth.
you.
I'm telling you, it looks
Thank
like
you.
I've seen a lot. I'm working in a hospital, and there's not a lot of people doing as well. Once they hit like 60, is downhill from there. So you're doing pretty well. I
Well,
have a
thank
question
you.
for you. What
Yeah.
does it mean to be biologically immortal? Because I read what you said in the Conquest
Mm-hmm.
of Death, the scientific
Mm-hmm.
conquest of death. It was a
Mm-hmm.
book about with a bunch of scientists, and they spoke about uh, their idea of how to reverse the aging process. And Dr. Michael Rose was in there in that book. I love that book, by the way.
Uh, okay. So a simple summary of my career is that for the first 20 years of my career, I worked on the evolution and physiology of aging from about 75 to 95, 96.
Wow.
For the last 25 years, I've worked on the evolution of immortality and the genomics underlying both aging and immortality. And that wasn't really by my choice. In 1992, a couple of colleagues of mine, Jim Kurtzinger and Jim Carey, published 2 articles in the journal Science, second best journal in scientific literature, where they showed that demographically aging stops.
Wow.
And almost everybody didn't believe it. But Jim Kurtzinger especially stuck with it, and he made an excellent case that aging stops. So that created the problem for me and my colleagues like Larry Muller. Why? Why does aging stop? That's just like so weird. It doesn't seem to make any theoretical sense. And in the 1990s, we developed a theory for why aging stops. And then we spent about 10 years testing that theory, resulting in a book in 2011 called Does Aging Stop?, which also explains why aging stops. And also we showed in the 2000s that we could change the age at which aging stops. And in the last 5 years, with my graduate student Grant Rutledge, we worked on how you might get human aging to stop at different ages. And we have 2 papers on that just came out this month.
Wow.
And you can get them both online.
Wow.
Rutledge, Rutledge, a first author. So, when I started working on aging in the mid-70s, it was like nobody believed that you could change it, me included. I was one of the first to deliberately postpone aging, to manipulate it in a lab with real live organisms. And over the last 40 years, there's just more and more evidence that aging is something we can defeat. So really the problem becomes, okay, show me the details. And in my 4 steps paper from 2016, I give a 4-step plan for how we will defeat aging. And I mean that in the same sense that we've defeated infectious disease. It's not that nobody dies of infectious disease, God knows, especially this year. But in a normal year, a small percentage of the population dies of infectious disease. Unfortunately, in a normal year, much higher percentages die of the diseases of aging: cardiovascular disease, cerebrovascular disease, cancer, kidney disease and failure, liver failure, Alzheimer's. Okay? So aging is the scourge, the disaster that we face now, in the same way that 150 years ago, infectious disease like tuberculosis and influenza were the scourges. Okay?
Right.
But just as over the last 150 years, we have defeated infectious disease fundamentally. Of course, when a new infectious disease comes around, we have to turn and face it. But we now have all the science we need and much of the technology. Right now, my view is we have all the science we need to defeat aging, and the project is to develop the technology. That's the real project right now.
And what type of technology do you see? I mean, you mentioned artificial intelligence being able to collect a large amount of data, which no human being by themselves can compare all the different pieces of data that the artificial intelligence and machine learning can come up with and draw conclusions from. What other type of technology do you see will help with this endeavor of reversing the aging process?
Well, for the next 30 or 40 years, I think the key technology is the cross between omics, which is genomics, transcriptomics, metabolomics, and machine learning as it now exists, and the more powerful AIs that will come soon.
Right.
Okay? So machine learning, which we have now, is pretty stupid.
Right.
It's not that artificially intelligent. But it is good enough to make enormous sense out of genomics and transcriptomics and aging and how all those things combine. In fact, we now have put a paper in bioRxiv on exactly that problem just this month. First author Barter, Barter, Thomas Barter in bioRxiv.
Thomas Watt,
We
okay.
have a beautiful paper which basically shows how we can use machine learning to make sense of all the molecular details of post-cloning aging.
Mm-hmm.
And as we make better and better sense of how evolution did it, we'll get better and better ideas about how to emulate evolution using pharmaceuticals or supplements.
Mm. I wonder what type of pharmaceuticals that'll be. Um, can you? Oh, you're gonna. I would definitely answer that. Let me give you. Go ahead.
Okay, yeah, I have an answer to that.
Definitely.
So
Let's save it.
the first step will be taking all the different pharmaceuticals we have for each biological problem
Mm-hmm.
and investigating them using a combination of living organisms, their omics, and machine learning to figure out which drugs are worse and which drugs are better in
Mm-hmm.
terms of their long-term effects on aging.
Mm-hmm.
So there's this really weird thing in the uh, corona epidemic,
Mm-hmm.
the COVID-19 epidemic, which they discovered in China. And in China, like much of the West, heartburn in middle-aged people is a very common problem.
Mm-hmm.
And it turned out that people who take omeprazole, which like brand names like Prilosec, have a much higher death rate with coronavirus infection than people taking famotidine, most common brand name being Pepcid.
Mm-hmm.
So, like when Donald Trump came down with the coronavirus, they gave him Pepcid,
Right.
which is like crazy.
Wow.
But now that was discovered because in a pandemic, a lot of people die.
Right.
So you can find out the answers to a lot of dicey questions about drugs very fast that way.
Mm-hmm.
Um, with aging, even though it is, in a sense, epidemic, and also in other sense, pandemic,
Mm-hmm.
because deaths from aging are spreading all around the world and it's becoming more and more common as a cause of death almost everywhere,
Mm-hmm.
the data are kind of slow. So we have to use more powerful tools like genomics and transcriptomics and metabolomics to penetrate into the complexity of aging.
Mm-hmm. Um, are you on metformin?
No,
Okay.
no,
Yeah, because I.
no. I only take medications that doctors prescribe for me.
Right.
Okay,
All right.
so I mean, I have an ambition, especially when I retire and spend more time consulting for pharma companies. I have an ambition to really help sort out which are the best medications of the ones that already exist
Right.
for helping with chronic aging associated diseases.
Right.
That's sort of the next thing I want to do with my life.
Sounds awesome. Um, what uh, what are some of the organisms that are biological immortal, and what's some of the uh, like the jellyfish in the animal kingdom is
Uh-huh.
biologically immortal using transdifferentiation? Can you explain to me? Can you let my
Sure.
yeah.
Um, so there are three kinds of organisms, plant, animal, or microbial, in the
Microbial.
world. The ones that we're most used to are the ones that age.
Mm-hmm.
Sometime after the start of reproduction, um, we start to lose it physiologically, and slowly our disease rates and then our death rates creep up.
Mm-hmm.
There are other species that never age at all. And famous examples of those are sea anemones that reproduce by splitting in two,
Mm-hmm.
but also things that a lot of people have seen, like creosote bushes, which are very common in the Mojave Desert,
Right.
that you drive through when you go between Vegas and LA.
Mm-hmm.
Juniper,
Juniper.
which is a common ornamental shrub in the Midwest. Trembling aspen, which is everywhere in a band from the east side of the Rocky Mountains up through places like New York State and Ontario, Canada. You can be looking at a bunch of trembling aspen trees, and those trees could have been standing there for thousands of years.
Wow. It's incredible.
Okay? Yeah. And there's a third very rare kind of organism, and you referred to it. One example of it is a jellyfish,
Mm-hmm.
which can go backwards and forwards with aging
Wow.
and completely regenerate itself.
Incredible. This is
Those are the
without
rarest.
technology, people.
That is entirely without technology. So,
It's
so
crazy.
it's an illustration of my most important principle, which is evolution totally rules. Okay? You want to be on the side of the most powerful force in the living world, you're on the side of evolution by natural
Right.
selection.
Right.
And if you try to go against it, you're an idiot.
Right.
You know,
Right.
unfortunately, a lot of people in NIH and some molecular reductionist community try to ignore evolution by natural selection.
Right.
Some of them are certain types of fundamentalist Christians who don't
Right.
believe in evolution by natural selection. And others are biologists who would rather that evolutionary biology would just go away and not bother them, especially in the aging research community where they really don't even want to hear about it.
Mm.
But the tragedy is that aging is not a result of one, two, three, or seven physiological processes. Okay. It's a result of hundreds.
That's right.
How do you make sense of that? Use the combination of evolutionary biology, omic technology, and machine learning or AI.
Wow.
And it can be done.
Right. 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 Wow. Um. And yeah, guess how many people die of age-related diseases in one day around the world? What's the number for that? You think?
Well, in the United States, I think it's somewhat more than 70% of all deaths in a non COVID year will be due to aging associated diseases. So it's still true that more people die of cardiovascular disease and cancer without ever contracting the coronavirus than die of the coronavirus
Right.
in this year, 2020.
Wow.
So I was actually just looking at the numbers, and the annual death rate from cardiovascular disease is around 600,000 a year. The annual death rate for cancer is 500, 550,000 a year.
Wow.
Plus, you have the diseases from the deaths, I should say, from the diseases like Alzheimer's disease, kidney failure, and so on, which are separate from cardiovascular disease and cancer. So, roughly speaking, in the United States, every year between 1 million and 1.5 million people die of aging associated diseases. And this year, tragically, probably more than 300,000 will die of the coronavirus, which is appalling.
Wow.
But that would be a good year for
Wow.
aging associated diseases. So my ambition for the rest of my life and ever after, let's say the things that I start now, is to crush aging in the same way we crushed infectious disease from 1870 to 2020. Doesn't mean you can't die of infectious disease, as goodness knows this year illustrates, but normally infectious disease is a small fraction of deaths
Right.
in a year, like a few percent. So I believe that in the year 2120,
Mm-hmm.
a century from now,
Wow.
only a few percent of people will normally die of an aging associated disease.
Incredible. That makes sense to me. Look how much the penicillin, how many lives penicillin itself saved. Just penicillin, the drug penicillin.
Well, let me tell you something very important.
Mm.
Far more people's lives were saved just by accepting the germ theory of disease between 1870 and
Mm.
1914 than were ever saved by penicillin.
Mm.
That's when we turned the corner with infectious disease,
Right. Right.
because that's when people started washing their hands, purifying their water, pasteurizing their milk,
Right.
and taking care of the canning process so that there wouldn't be any bacteria put in the can
Right. Right.
with the food that you put in the can. Okay?
Right.
That's when we started to refrigerate everything, and so on and so on. In the same way, accepting the evolutionary theory of aging leads you to things like the paleo lifestyle for those over 40. It leads you away from high fructose corn syrup, Red Bull, Twinkies, seed oils, all the nasty stuff with which we destroy our health.
That's right. Yeah.
It is those things that have given rise to an epidemic of cardiovascular disease and cancer
Yes.
over the last 150 years. Those industrial grade foods, which 200 years ago no one ever ate.
Right.
So nobody is adapted in an evolutionary genetic sense to consuming the Twinkies Red Bull diet.
Right.
It's pure poison,
Right.
but they're allowed to sell it because it's big food, capital PHOOD.
Wow.
Okay? So just by people finally accepting steps 1 and 2 of my 4 steps, first one being accept that aging is a product of evolution. Evolution doesn't want you to age, it can banish it easily. Okay? And the second step is adjusting your lifestyle in an age and ancestry appropriate way to make the best of what evolution gave your genome.
Wow.
And none of that second point is going to make big food happy.
Right. What are the last two? Can you share with us the last 2 steps?
So step number 3, in my opinion, started this year. Step number 3 is we've got our first really powerful AI-omic paper
Right, you said that.
put into bioRxiv. It's under scientific review. It will certainly be changed from the bioRxiv version. And but there we're showing how you can use machine learning to completely open up how the genomics define the transcriptomics of postponing aging, of doubling lifespan. How do you have to change the genome? How do you have to change the transcriptome to double lifespan? So if we could double normal human lifespan, people would be routinely living 150, 160 years.
That's incredible.
Okay?
Wow.
So the project, and a project I embrace for the rest of my career, step 3, which is using every kind of tool we can just sort of MacGyver together. In the same way vaccines and antibiotics were MacGyvered together before 1950, when we really didn't know the science of infectious disease that well. But we knew enough. So we knew enough to come up with little piecemeal solutions like antibiotics, like vaccination, like pasteurization, to get infectious disease on the run. After 1970, molecular biologists and cell biologists did a fantastic job figuring out all the little details of molecular and cell biology underlying infectious disease. But by then, it was largely defeated. Okay? So my hope is that over the next 30 years, we can largely defeat aging. Not reducing it to the level that I think we'll achieve after step 4, where we massively figure out what's going on.
Right.
But let's just say over the next 50 years, from 2020 to 2070, we will take aging down a very big notch.
Wow.
And take it from 70% of deaths to like 10 or 20% of deaths.
Wow.
Make a big, huge dent and thereby increase lifespan to average lifespan into the, somewhere between 100 and 200.
Wow. Incredible.
I feel that's doable over the next 30 to 50 years.
Wow. You hear that, people? That's good news about Dr. Michael Rose. And I'm telling you, I trust what he says. I really trust what he says. Why is defeating aging I know this is, this question, I already know the answer to this question, but I have to ask this question for people. Because I know there's people out there that still are doubters, and they don't like the fact that we're talking about reversing the aging process. They think it's not a worthy cause or priority for science to fight this cause. What do you have to say to people who think that working on reversing the aging process is unworthy of our attention and our efforts?
The first thing I would say is that's exactly what the Catholic Church said about defeating contagious disease in the 19th century.
Wow.
A lot of people don't know that in the middle of the 19th century, around the 1850s, The Catholic Church was really opposed to attempts to defeat infectious disease
Wow.
because they regarded it as God's work.
Right.
In the same way, many people now regard aging as God's work. But of course, unless God is doing spooky things in my lab,
Right.
I've shown experimentally that aging is not God's work.
Right.
It's not immutable. It's not ordained from on high.
That's
It is a perfectly ordinary product of evolution, which we can change.
right. Right.
So there's nothing divine. There's nothing specially ordained about aging. There's nothing immutable about aging. Aging is just as ordinary, but just as deadly
Right.
as untreated infectious disease.
Wow.
To me,
Wonderful.
ethically, it's no different.
Right. Me too. Me too. Wow. Um. Oh, yeah. I hear a lot of people say, "Well, aging is a disease." Even I got sucked into that type of ideology, thinking is that aging is a disease. How would you frame aging at? I don't. I think I overheard you say that you don't believe aging is a disease. Why not?
Well, scientifically, it isn't. If any reasonable scientific definition of disease would be that it be something unusual that happens to a subset of a population. But aging is something that will happen to all of us if we don't die of some type of accident or infection first. Okay? So aging is totally normal, and that's why a lot of physicians resist the redefinition of aging as a disease. But in a more profound sense, calling aging a disease is also a mistake. And that more profound sense is it gives people an illusion about what aging is. Aging is not some special, specific process of what physicians call pathology.
Right.
Okay? Aging is the opposite of what you experience, what 90%, 95% of everybody experiences in the first 20 years of their lives. In the first 20 years of your life, you are rising toward greater and greater power, better use of your brain, better use of your body, better capacity to do all kinds of important functional things. To evolution, most importantly, to reproduce,
Mm-hmm.
which in our species means doing a whole lot of things, like accumulating resources, impressing the opposite sex. You know the drill.
Right.
We've all lived through that.
Yes. We do.
Uh, for me, mostly in the rearview mirror.
Mm.
Um, and then at exactly the point in time when evolutionary biology says you're going to start to lose all of that amazing health,
Mm-hmm.
you do. You start to lose it.
Mm-hmm.
Because health is what in evolutionary biology is called adaptation.
Right.
It's called Darwinian fitness.
Right. Right.
It's your ability to do all of the things that evolution built your body to do.
Mm.
And the sad truth of natural selection is that the farther away you get from the first stage of reproduction in a population, the less natural selection cares about keeping you alive.
Right.
Aging is not a physiological process.
Right. Mm.
It is the detuning of adaptation, which means the detuning of health.
Mm.
You progressively lose it. Okay? The foundations of your health are slipping away.
Mm.
So you can't address that using the kinds of approaches that do indeed work
Mm.
for infectious disease or what are called genetic diseases, where you have a very specific major defect, like sickle cell anemia
Mm.
or cystic fibrosis.
Yeah.
Those have
That's right.
those have very specific, well understood causes, and they are diseases.
Right. Shout outs to my cystic fibrosis patients. We have them in my department. Well, they come to my department all the time. Shout outs to all of
And
them.
you will agree, they have a disease.
Right. Right.
They have a devastating disease,
Yeah. It's
as do people with COVID-19.
right. Right. Right.
Those are diseases.
Mm.
Aging is in a different category.
Mm.
Okay. And, it would be really nice to have it labeled as a disease. But if you look in detail at what it means to have a disease, aging doesn't fit that definition.
Mm.
Aging is instead better thought of as the inverse of health upside down.
Mm.
As you undergo aging, you are losing the foundations of your health, because the foundation of health is adaptation, and adaptation is built by evolution, by natural selection.
Right, right. Wow.
Okay? And once you accept that conceptually, then you can start to make serious progress.
Mm. Mm. Wow. Wow. Um, Let me ask you, is creating a Manhattan Project to defeat aging a real thing still? Is there a bunch of scientists that's like, look, we're going to work together. We're going to figure this out. We got to figure this out. Time
So
is running out.
I proposed that concept at a meeting in Bar Harbor in 1988.
It's a great idea, by the way.
And that was discussed in Time Magazine, Life Magazine, Newsweek, The Economist.
Mm-hmm.
And I was given some pilot funding to start a Manhattan Project on Aging by NIA.
Wow.
And that started in 89,
The NIA is the National Institute for Aging.
National Institute on Aging.
All right.
And then what happened starting around 1991
Mm-hmm.
is the cell molecular biologist came in and took the money away from me and the team I was trying to assemble.
All right.
And they said, no, 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 no. We're not going to do this your way. We're going to do this our way. So that happened 30 years ago. And how much progress did they make in 30 years?
Not much.
Not much.
Yeah, it's not much at all. Oh boy.
Of course, you will never get an academic or a government bureaucrat to admit they made a mistake.
Right. Right.
Okay?
Right.
That doesn't happen.
Yeah.
So basically, I'm just waiting for them to retire or die.
Right. Right. Wow. Um, what kind of advice can you give to the young hip hop scientists looking to join a cause to reverse the aging process? These young hip hop scientists I'm trying to reach. What advice can you give
Well,
them?
step one of the 4 steps is getting with scientific truth.
Mm.
And I produced, together with Rob Patterson, a website called 55 Theses, THESES, numerals 55,
Mm-hmm.
deliberately emulating Martin Luther's 95 Theses, which he nailed onto a cathedral door, more than 500 years ago. Okay. As a challenge to orthodoxy in the aging field, and as a guide to smart people who may not be scientists, who would like to learn, what time it is.
Right.
And the 55 Theses are 55 sentences,
Mm-hmm.
and each sentence is explained by about a page of text and a podcast.
Mm-hmm.
And actually, the podcasts are the thing to start with.
Mm-hmm.
So first you listen to my podcasts, and you may experience falling asleep because I don't have the most exciting delivery.
It's okay.
Um,
We will look at it. We will listen.
Once you're good with the podcast, you read the sentence,
Mm-hmm.
then you read the roughly page, and it's got no diagrams, no data, no math.
Mm-hmm.
Underlying every one of those pages is tons of data, tons of math,
Wow.
tons of diagrams, but I'm just trying to render it in English language words.
Mm-hmm.
Now, it's not easy sledding, but I think anybody who's brave enough to get through that material on that website, they'll get with the program step one, getting with the scientific foundations of what's going on.
Right.
Step two is the age-appropriate diet,
Right.
age and ancestry appropriate. If you come from, the jungle of Congo or the jungle of New Zealand or the great deserts of Australia, you should never touch any agricultural or industrial foods at any time in your life.
Wow.
100% stay away from all of it.
Wow.
If you're Eurasian like myself and billions of other people, then when you're young, you can eat a healthy, organic version of an agricultural diet.
Mm.
Certainly until you're 20, maybe until you're 30, but by the time you're 40 or 50, it's over.
Wow.
And over the age of 50, we're all in the same boat. We're no longer adapted to an agricultural diet. We were never adapted to an industrial diet or lifestyle. So that also means activity patterns. Like as industrial and dangerous as the Twinkie Red Bull diet
Right.
is sitting on our tails looking at screens all day, which unfortunately is what we're doing this year.
Yeah.
Except for those of you who work in hospitals and grocery stores,
Yeah.
who are truly the essential workers,
Mm.
not people like me.
Mm.
But once COVID is over, go back to activity.
Mm.
And by activity, I don't mean training for a marathon. I mean, just being active,
Right.
walking, sometimes running, sometimes going to the gym. But you don't have to become a total gym rat,
Right.
you know? So being active.
Mm.
And step 3 is the combination of AI and omic technologies,
Mm.
which, I'm working on at the
Mm.
university, and soon I will be leaving the university to work on it in the private sector.
Mm.
And first step, we'll try to figure out which drugs are better than others,
Mm.
prescription drugs. So, and even over-the-counter drugs and supplements, it's all the same thing.
Wow.
The difference between over-the-counter drugs and supplements and prescription drugs is just a question of law. They can all be bad for your health, and they
That's
can
right.
all be good for your health. And right now, we don't know enough
Mm.
about which are good and which are bad. And I'd like to find out.
Mm. Has metformin has the FDA approved metformin as an anti-aging drug yet? No, right?
To my knowledge, the FDA has not approved any drug as an anti-aging drug,
Right, right. That's what the
but they are doing a trial involving metformin.
wow. Okay.
Okay,
Wow.
so possibly metformin is one of those good drugs.
Wow.
Okay, and I mean, I have to say, in my opinion, and I think there's a lot of data to support this, vitamin D3 is one of the very best supplements.
Yeah, it sure is.
And I'm not saying people should take 10,000 IUs a day,
Right. Right.
but I think most people should be on at least 1 or 2,000
One, 2,000.
IUs a day.
Yeah,
And
I
that's the only supplement I routinely recommend. And that's
mm.
with K2, vitamin K2.
K2, right. I take both of those, right.
Uh, Large doses of A, C, and E, vitamins A, C, and E can be toxic.
Wow. Wow.
Large doses of a number of commonly used supplements can be toxic.
Right.
And there are even some supplements that people take that I think maybe even be routinely toxic.
Wow.
Okay. So to be honest with you, I don't, I mean, I have mixed feelings about any prescription drug, even though if a doctor prescribes them to me, I will take them.
Mm.
I definitely have very mixed feelings about supplements, even though I take a handful of supplements
Right.
if I feel the evidence is pretty much overwhelming.
Right.
For vitamin D3 plus K2, I think the evidence is overwhelming.
Yeah.
But even there, I think moderate consumption rather than mega doses every day.
Mm. Wow. Do you think we'll be able to reanimate patients out of cryonic suspension in the future? Are you a cryonicist, Dr. Michael Rose?
So about 20 years ago,
Mm-hmm.
well, I'll say, yeah, about 20 years ago, I thought of a cryonic project that I wanted to do,
Mm-hmm.
which would have been focused on reanimating multicellular animals. Okay. I think of cryonics as a technological project.
Right.
I think that people like Greg Fahey are doing excellent work on that
Yeah.
technological project.
I do so too. Yeah.
And I hope that someday it becomes a viable technology.
Mm-hmm.
However, concretely, even though I'm very good friends with a lot of people involved in Alcor, including their CEO,
Mm-hmm.
I don't have an Alcor contract for cryopreservation.
Mm,
That
wow.
doesn't mean that in 10 or 15 years, I might not become
Right.
an Alcor client.
Right.
Once I've seen good enough organ resuscitation from cryonic
Right.
preservation. And I think we're getting close.
Right. Well, Dr. Greg, how do you say his last name?
Faye.
Frey. Yeah. I think that brother came up with the vitrification process where it's like
Yep.
ice. It's like it doesn't
Yep.
damage ice. It doesn't damage tissue. What's
Well,
it
it
called?
basically his idea is supercooling with while minimizing ice
Ice
crystals,
crystal damage. Right.
right? By minimizing the actual occurrence of ice crystals.
Right. Thank you. Oh
Yeah.
wow. Yeah, this is great. Now every day, people we get to talk to an evolutionary biologist about the process of race and aging. I mean, kids, boys and girls, ladies and gentlemen, this has been an eye opener, and we really appreciate it here at Super Longevity Institute that you're talking to hip hoppers because in the inner city we have so much other troubles and so many other things plaguing our environment. This message gets unheard, like, but you know what? There might be a child in the inner city who, from young, wants to that's thinking about these ideas and want to pursue a career like Dr. Michael Rose. He's giving so much time and putting so much effort in trying to find what's why we're aging and trying to find out what we can do about it. It's very noble, and I really appreciate it. And you inspired me because I mentioned you in the song "Betrayal One" in Hip Hop State. When I found out that you reversed that you dealt with the lifespan of fruit flies, I said, "This is the man." Okay, he demonstrated this. He's demonstrated something, you know, that we can go
Well,
back
thank
to
you.
and further develop because so I salute you, Dr. Michael Rose, and thank you for inspiring me. I wanted to tell you that on camera personally.
Well, thank you for having me. It's been fun talking to you,
Yes,
and
thank you.
I'd be happy to do it again.
Oh yeah, we're gonna have you back on. We need more. We would love to have you back on, and just keep. I'm glad you're keeping up the fight. And for people who don't think reversing the aging process is a good thing, I mean, your parents are aging. I mean, don't you love your parents? Wouldn't you like to see? I mean, who don't love their mother? It's like,
Well, well,
it's like,
and it, unfortunately, it has to be said. Dude, you're aging.
yeah,
I mean, aging starts around 14 to 18.
that's right. That's
Yeah.
right.
So even though you're not likely to die of aging related diseases between the ages of 20 and 40 or 45, you are aging. It's happening to you.
Yeah, I mean, I know that my work will be the work that I'm trying to do. It will be successful once I can get a youngster who went to the university, graduated, took evolutionary biology, took a bunch of courses, and say, you know what, this is my life mission, is to do what the gentleman Dr. Michael Rose did and put in as much work as he did and further the pursuit. I know I did my job. If I can just get one person, if I can reach one person, I know I did my job. Oh,
I'm pretty sure you're going to succeed,
thank you, Dr. Michael
and
Rose.
on a big scale.
Thank you, man. And you're always welcome here. If you, we're gonna definitely have you back on the podcast. Really, one of my future goals is to take this. I really want to sign on to Sirius Radio eventually and bring this futurism, transhumanism, anti-aging uh, thing to Sirius Radio in the future. That's my future endeavors. So, anything you would like to say? Any websites that you would like to share with my audience, share with these hip hoppers, where they could find your work and keep up with what you're doing? Because I think is amazing, and we need to keep up.
Well, I have a website I did um, around 10 years ago, the 55 Theses,
Mm-hmm.
55 THESES.
Mm-hmm.
Um, I would love to have the time to do a website that gets updated regularly. So if you know some people who'd like to do that with me, that would be great.
I do.
So let's think about that.
Okay.
For now, you can find me on Google Scholar, where I have a page,
Okay.
Michael R. Rose. Middle initial is important because there's so many Michael Roses.
All right.
It's not as bad as John Smith, but it's up there.
Yeah, sure.
And you can see our latest publications
Okay.
right there on Google Scholar on my page.
Wonderful. I will definitely put a link underneath the description so people could just hit the description link and they can just go right to your website. Wonderful. I'm Lord Maitreya with the Super Longevity Institute podcast, and he's Dr. Michael Rose. Thank you again. Have a wonderful
Thank
night,
you.
and we'll see you
You
after
too.
elections. See you after
Yes.
elections.
Uh,
We'll see you when this all blows over.
exactly.
All right.
Thank you.
Thank you, man. Appreciate you.
My pleasure.
Bye.
Bye.